Okay, this is the paper review for 2019 November paper 1. Let's go. Question 1. The probability distribution function of a discrete random variable x is given by the following table. Find the value of p. So first step to do is to realize that the total probability is 1. So the sum of all the probabilities is equals to 1. And so therefore half plus 1 over 5 plus 1 over 5 plus p is equals to 1, and so therefore p is equals to 1 minus the sum of all those numbers, which is 1 over 10. Part B, given that ex is equals to 10, so let's find that. So sum over all x of x times probability of x equals to x, that's the definition of ex, is 10. So that means that 1 times half plus 1/5 times 5 plus 1/5 times 10 plus n times p, which is 1 over 10 times n, is equals to 10. Okay, so this means that n overall is equals to 65. Question 2, given that integral of 0 to ln k of e to the power of 2x dx equals to half, find the value of k. So let's evaluate this. This is half e to the power of 2x evaluated from 0 to ln k, equal to 12. So therefore half e to the power of 2 ln k minus half e to the power of 0 equals to 12. Half e to the power of 2 ln k will be 12 plus half, right, times 2 overall. E to the power of ln k square equals to 24 plus 1, which is 25. Alright, and so this means that k square is equals to 25. Why is that so? Because e to the power of ln x is equals to x. Okay, this is a reverse, okay, the inverse function, because e and ln are actually inverse functions. Okay, this is one of the identities that you would have learned back in year 5. So k squared equals to 25, so k equals to 5 or minus 5. Okay, but we can't include minus 5, okay, because that will render ln k undefined. So therefore k equals to 5. Question 3. Okay, the three planes have these equations, so let's form a augmented matrix. Okay, 2 minus 1 1 5, 1 3 minus 1 4, 3 minus 5 a b. Okay, let's do some row operations. Okay, so here, first step I would do, maybe I would swap row 1 and row 2. Okay, I actually don't really need to write it in the same order. Okay, I could reword it, and actually it's a good idea to put the very first number over here as 1. Okay, this is a very good idea. So in fact, actually I could have just put this down as the first row straight away, okay, without having to swap the 2 rows. Okay, but oh well, never mind. So let's do it now properly. Row 2, okay, becomes row 2 minus 2 row 1. Row 3 becomes row 3 minus 3 row 1. Okay, giving me 0. Minus 1 minus 6 is minus 7. 1 minus 2 is 1 plus 2 is 3. 5 minus 8 is minus 3. 0 here, minus 5 minus 9, that's minus 14. A plus 3 and b minus 12. Okay, like this. Then let's see, we can then take some steps to make this element here 0. Okay, we're going to make this 0, so I'm going to take row 3 to become row 3 minus 2 row 2. 1 3 minus 1 4, 0 minus 7 3 minus 3, 0 0 a minus 3, b minus 6. Okay, and we want there to be no points of intersection. Okay, this means that there is actually no solution of the 3 simultaneous equations. So therefore that means that we must have a minus 3 equals to 0, okay, and b minus 6 not equals to 0. Okay, therefore giving me a situation where the last row is actually a equation which doesn't make sense, okay, because you have 0 equals to something that's not 0. So A equals to 3, okay, and B is not equals to 6. Okay, that's the answer. Question 4. A and B are acute angles such that cosine A is 2/3, sine B is 1/3. Show that cosine A 2A plus B equals to something. So cosine A equals to 2/3. Okay, that tells you straight away, alright, that you can draw a triangle like this. This is A. Cosine A is 2/3. This means that this side must be root of 9 minus 4, which is root of 5. Similarly, sine B equals to 1/3. Okay, right, that means that this is the triangle, okay, that we have B. This is 1 and 3, this side being 9 minus 1, which is root 8. Okay, so we can actually find sine A. Okay, immediately sine A is root 5 over 3, and cosine B, immediately we can see that it's root 8 over 3. So let's do this now. Cosine of 2A plus B, we know what we need to work towards. So let's just make sure we get there. So let's use double angle formula, or addition formula rather. Cosine 2A cosine B minus sine 2A sine B. Okay. And let's work this out again. Cosine square A minus sine square A times cosine B. Okay, minus 2 sine A cosine A. Okay, sine B. Okay, then now it's a matter of putting in all the details. So this is 2/3 square minus sine A root 5 over 3 square times cosine B root 8 over 3 minus, okay, 2 minus 2 times sine A root 5 over 3 cosine A 2/3 times sine B 1 over 3. Right. Okay, so this is equals to, then let's work it out, 4 over 9 minus 5 over 9 times root 8 over 3 minus 2 times root 5 times 2, that's 4 root 5 over 27. Okay, you can see that when I evaluated this, I get this straight away, so that is kind of a hint that I'm good, I'm correct. Now it's only a matter of this one that is, hopefully it simplifies, okay, into what I want. Alright, so this is, let's see, this is minus 1 over 9 times root 8 over 3, okay, times 4 root 5 over 27. The denominator is root 27, but the numerator is not quite 2 root 2 yet, except that if you look at root 8, you can simplify it to root of 4 times 2. Root of 4 times 2, which is root of 2 times 2, right? 2 root 2. Okay, so this is minus 2 root 2 over 27 minus 4 root 5 over 27. Okay, and we are done. Okay. Now, it's very important to show this step, okay, over here, because this is actually the step we are looking out for, especially when the question is a show question. Okay, so if you were to jump from this step to this step, okay, you might lose, okay, a mark. So show all the working that you have. Question 5, consider this equation, z to the power of 4 equals to minus 4. So solve the equation now. Let's do that. Z to the power of 4 equals to minus 4. That's actually 4e to the power of I pi. And then to generate more roots, we add 2k pi to the argument. Okay, so this means that z is actually root 2, okay, times e to the power of I pi over 4 plus 2k pi over 4, for k equals to 4 numbers 0, 1 and 2. Now we need to give the solutions in the form a plus ib. Okay, so let's substitute. So if you let k equals to 0, what happens? K equals to 0 gives me z equals to root 2 e to the power of I pi over 4, okay, which is root 2 times cosine pi over 4 plus I sine pi over 4, right? Okay, which is equals to root 2 times 1 over root 2 plus I over I times 1 over root 2, okay, which is 1 plus I. Right, when k equals to 1, right, what happens? Z is root 2 times e to the power of I pi over 4 plus pi over 2. Okay, which is root 2 times cosine 3 pi over 4 plus I sine 3 pi over 4. Now cosine 3 pi over 4 is minus 1 over root 2. Sine 3 pi over 4 is 1 over root 2. So this is minus 1 plus I. Minus 1 plus I. Now you can notice that here, the equation over here, okay, is a equation where all the coefficients are real. Right, so that means that the conjugates are actually, okay, roots as well. Okay, so now if you look at these two solutions that we have here, okay, they are not conjugates, so therefore they must both be kind of distinct in terms of the solutions that we have, and when we take their conjugates as roots, they will also find the other two roots, okay, and they will therefore be the ones corresponding to minus 1 and 2, okay, appropriately. Alright, so I can just say that therefore, okay, 1 minus I and minus 1 minus I are also roots, okay, okay, as all the coefficients are real, okay, and so therefore, alright, the roots, okay, are these four numbers: 1 plus I, 1 minus I, minus 1 plus I, and minus 1 minus I. Part B, the solutions form the vertices of a polygon. Find the area. So let's draw the Argand diagram and let's plot these 4 points. So if you look carefully, it turns out that these 4 points are on these 4 positions over here, okay, all 1 unit away, okay, from the origin. So that means that this, okay, polygon is actually a square, okay, and so the area is very easily found by taking the 2 sides multiplied by each other. Okay, each side has length 2 because this is wall length 1 each. This is 2 as well. So the area is 2 times 2, which is 4 units square. Question 6. Consider the function fx equals to x e to the power of 2x. Prove by mathematical induction that the nth derivative is 2 to the power of nx plus n times 2 to the power of n minus 1 e to the power of 2x. So let's state our proposition first. Let Pn be the proposition that Fn Fnx is equals to 2 to the power of nx plus n times 2 to the power of n minus 1 e to the power of 2x. Okay, for n being an integer, and here fx is equals to x e to the power of 2x. So to prove P1 is true, first we need to use differentiation to actually find the derivative. That's going to be e to the power of 2x plus 2e to the power of 2x times x, right, which is equals to e to the power of 2x times 2x plus 1. Okay, and on the right hand side, if we use the formula, we get 2 to the power of 1x plus 1 times 2 to the power of 0 times e to the power of 2x, which is, well, e to the power of 2x times 2x plus 1. So therefore, we can see that P1 is really true. Now we assume that Pk is true. Okay, that means that the kth derivative of x is really equals to 2 to the power of kx plus k times 2 to the power of k minus 1 e to the power of 2x. Okay, and the idea is that we really need to use this, okay, expression when we prove that pk plus 1 is true. So the left hand side now of pk plus 1, right, is actually the k plus 1th derivative of f, which is actually going to be the derivative of the kth derivative of x, okay, which is how we bring in the pk plus 1 statement. Okay, so we're going to differentiate, okay, this 2 to the power of kx plus k times 2 to the power of k minus 1 e to the power of 2x. Alright, so let's do it now. So product rule, this is 2 to the power of k, alright, plus 0 e to the power of 2x plus, then leave this alone, plus k e to the power of 2 to the power of k minus 1 times 2e to the power of 2x. Right, let's factorize e to the power of 2x. So that's 2 to the power of k plus 2 to the power of k plus 1x plus 2k times 2 to the power of k minus 1, which is actually 2 to the power of k. Okay, so this is e to the power of 2x times 2 to the power of k plus 1x plus 2 to the power of k times k plus 1. Okay, now which is, if you look at it carefully, it's actually really the right hand side of pk plus 1, okay, because this is 2 to the power of k plus 1x plus k plus 1 times 2 to the power of k plus 1 then minus 1, okay, which is the right hand side of pk plus 1. Okay, but we need to write the final statement. So since P1 is true, okay, and PK true, implies that PK plus 1 is true, right, by mathematical induction. There's no hitch here. Pn is true for all n integers. Alright. Question 7a. Write this expression in the form a times x minus h squared plus k. So that's a completing the square expression. So I'm going to write it as this first to make the coefficient of x 1. Then I notice that I need to plus 1 to this, but I will minus 1 so as to not change the expression. And so I get minus of x minus 1 square minus 1, which is 1 minus x minus 1 square. Okay, part B now. Hence find the value of integral half to 3 over 2, okay, of 1 over root of 2x minus x squared. Okay, so this is really equals to, as I've seen earlier, the integral of half to 3 over 2 or 1 over root of 1 minus x minus 1 square. So the integral is actually an arc sine, okay, function. So this is equals to integral, not integral, this is equals to arc sine of x minus 1, okay, from half to 3 over 2. So that's arc sine of 3 over 2 minus 1, which is half, minus arc sine of half minus 1, which is minus half. Okay, and that's pi over 6 minus pi over 6, which is pi over 3. Okay, in paper 1, the integrals, okay, the special angles will be in, right? So if you find yourself with some other fraction, something went wrong, okay, in your working. Question 8. A straight line, okay, has this equation, a plane has that equation. Show that the angle between L at theta and pi p is independent of both theta and p. So the aim here that we want to show is that this angle, right, does not depend, right, does not have any theta or p in the expression, okay. So let's just figure out what we need to do first. So let's draw a graph. Here we have our plane. The plane has normal vector 1, 0, 0. Okay, figure it out if you're not sure why. The line has some direction vector. I don't know why it is, but I don't know which way it points, but I know that for sure it's this, okay, expression. So as usual, okay, we observe that the angle between the line and the normal vector is, if it is this angle theta here, okay, the angle between the line and the plane is actually 90 degrees minus theta. Okay. Alright, so if we were to call this angle alpha, alright, then the angle between the line and the normal vector is actually 90 minus alpha instead. Alright, so I'm going to take the angle between the normal vector and the line, okay, then this is the normal vector, this is the line's direction vector, this is the normal vector, okay, of the plane. Right, and its angle, okay, will be 90 minus alpha. Right, so 5 sine theta cosine theta, okay, times mod of 100 cosine of 90 degrees minus alpha. Okay, where alpha is the angle between the line and the plane. So on the left hand side, I get 5, right, which is already independent of theta. That's good. Notice p doesn't even appear in the expression right now. Okay, so that should be good news for us. This is 5 square plus sine square theta plus cosine square theta. This is root of 1 square plus 0 square plus 0 square. And cosine 90 minus theta is actually sine of alpha. Okay, cosine 90 minus alpha is sine of alpha. So sine of alpha is going to be 5 over root 26 times root of 1, which is 5 over root 26. And so you can see that alpha is up sine of 5 over root 26. And this is independent of theta and p. And we're done. Alright, section B now. Let's continue with question 9. Question 9a, given that cosine 75 is q, show that cosine 105 degrees is negative q. So let's start with cosine 105 degrees. I observe that cosine 105 degrees is actually cosine of 180 degrees minus 75 degrees, which by the rules of trigonometry is negative cosine 75 degrees, okay, because 105 degrees is in the second quadrant, so that's equals to negative q as required. Part B, you have the following diagram. Okay, A, B, C, D are on the circumference of a circle. Alright, the radius of this circle is r, so these are r. BC is also r. AD equals to BC, okay, and angle ABC is equals to angle ADC equals to 90 degrees. So part B show that angle BAD is 75 degrees. So I note that angle BAD is actually angle BAC plus angle CAD. So let's find them separately. Okay, I'm going to find angle CAD first. So angle CAD, note that it is an isosceles triangle because DA equals to CD. So that's going to be 180 degrees minus 90 degrees divided by 2. Okay, why? Because triangle ACD is isosceles. Okay, so that gives me 45 degrees. Okay, 45 degrees. Now I look at angle BAC and I realize that sine of angle BAC is equals to r over 2r, which is half. So that means that angle BAC, okay, is equals to sine half, alright, which is equals to 30 degrees. Right, so therefore angle BAD, okay, is equals to 45 degrees plus 30 degrees, okay, and that gives me 75 degrees overall. Okay, part C, by considering triangle ABD, show that BD square equals to minus 5r square minus 2r square cubed root 6. So let's consider the triangle ABD now. Let's join here. It's ABD. I will need to find AB and AD now, because I know that this is 75 degrees right already. Okay, so let's see. So I know that AC is 2r. Okay, so and I also know that cosine of angle BAC, okay, is equals to AB, okay, over cos AC, which is 2r. So therefore AB is equals to cosine BAC, which is cosine 30 degrees, okay, and that's going to be root 3 over 2, okay, times 2r, and so that gives me AB to be root 3r. Okay, so at the same time, we also can find the side AD. Okay, so well, I can tell you that AD square plus CD square is actually 2r square, okay, by Pythagoras theorem. Okay, so this means that AD square, 2 times AD square rather, because AD equals to CD equals to 4r square. Okay, so AD square equals to 2r square, and so therefore AD equals to square root 2r. Okay, so this gives me a very nice triangle for cosine rule. So therefore BD square, the thing that I want, is equals to root 3r square plus root 2r square minus 2 times root 3r root 2r cosine 75 degrees, which was Q as shown in the first part of the question. So this is 3r squared plus 2r squared minus 2 times root 6r squared cosine 75, which is q. Okay, and then now we just need to rearrange to get the answer. Okay, part 2, by considering triangle CBD, find another expression. Okay, so CBD is this triangle over here. Alright, find another expression of BD squared in terms of R and Q. So let's see, I know that this angle is going to be 60 degrees. Why? Because this was 30 degrees and this is 90 degrees. So that must be 60 degrees. So this and this angle here has to be 45 degrees. So the whole thing is actually 105 degrees. Oh, also because this is a cyclic quadrilateral, okay, so these two angles must add up to 180 degrees. Okay, that's also true. Okay, so first thing I note, alright, angle BCD is equals to 180 minus 75 degrees, which is 105 degrees. Okay, because it's a cyclic quadrilateral. Okay, they are opposite angles in a cyclic quadrilateral. Alright, so now I also know that BC is R. I also know that CD, okay, it was the same as AD, which is actually root 2R. So I can find an expression now for BD. BD squared is equals to R squared plus root 2R squared minus 2 times R times root 2R cosine 105 degrees, which is negative q. So this is R squared plus 2R squared minus 2 root 2R squared times negative q, which is 3R squared plus 2 root 2q R squared. Alright, that's BD. Okay, part D now. Use your answers, alright, to show that cosine 75 degrees is 1 over root 6 plus root 2. Okay, part D now. Use your answers to show that cosine 75 is equals to 1 over root 6 plus root 2. So from part C, okay, we know that 5r squared minus 2r squared q root 6 must be equals to 3r squared plus 2r squared q root 2. Okay, why? Because, well, they are both expressions of BD squared. So let's solve this now. So I also know that cosine 75 is q, so I want to make q the subject of the formula. Okay, so this is what I'm going to do. I'm going to move this over here, this to the other side, and then I'm going to see what happens. Okay, so move on to the side. Q times 2r squared root 6 minus 2r squared root 2 is equals to 5r squared minus 3r squared. Okay, which is 2r squared. Okay, so on the left hand side, this is q, then times another 2r squared, then root 6 plus root 2, okay, equals to 2r squared. I can cancel the 2r squared, okay, and I can factorize q out. So q is 1 over root 6 plus root 2, and so therefore cosine 75 degrees is actually 1 over root 6 plus root 2. Okay, that's proven. Question 10. Question 10a. Consider fx equals to 2x minus 4 over x squared minus 1. Part A, part 1, find f prime x. So let's differentiate with respect to x. So that's v du dx minus u dv dx over v squared. Okay, so that gives me 2x squared minus 2 minus 4x squared plus 8x, okay, divided by x squared minus 1 squared. Okay, and then actually this is really the answer, but let me just simplify a bit more, okay, so that it's not so complicated. Right, part 2. show that if f prime x equals to 0, okay, then something is true. So f prime x equals to 0, that means that this fraction minus 2x squared plus 8x minus 2 over x squared minus 1 squared is equals to 0. Now, this is actually the numerator that will be 0 because the denominator doesn't contribute anything to making it 0. So therefore, I can say that x squared minus 4x plus 1 is equals to 0. Okay, now I can actually use the quadratic formula. So x is equals to minus b plus minus root of b squared minus 4ac over 2a. And so that gives me 2 plus minus half root of 12. Which is 2 plus minus 12 is 4 times 3, okay, so this is half plus minus root 3, okay, 2 plus minus root 3, okay, 2 plus minus root 3, and so I have to accept 2 minus root 3 because 2 plus root 3, right, is outside of the domain. As shown. Okay, B. For the graph of y equals to fx, find the coordinates of the x-intercepts. Okay, so this one I need to let x equals to 0. Right, so f of 0 is equals, what's f of 0? F of 0 is equals to 2 times 0 minus 4, okay, over 0 minus 1. Okay, so that's going to be minus 4 over minus 1, which is 4. So therefore, the coordinates, right, of the y-intercept, okay, are 0 and 4. Like this. Okay, part 2 show that there are no x-intercepts. So we let f of x equals to 0. Okay, so 2x minus 4 over x squared minus 1 equal to 0. And so therefore 2x minus 4 equal to 0, and so that means that x equals to 2. However, this is outside of the domain, okay, x between 1 and minus 1, so therefore there are no x-intercepts. Okay, this is really important to state that it's outside the domain, okay, because we want it to be within minus 1 to 1. Okay, so the domain becomes the part which makes it like there being no x-intercept at all. So it's important to state this. Okay, we really need to state this. The marking scheme says that this is an important reason that one needs to state. Part 3, sketch the graph showing clearly any asymptotic behavior. So we can also see that there are two vertical asymptotes. Okay, one at x equals to minus 1 and one at x equals to 1. Okay, so we know that there is a turning y-intercept at 0, 4. Okay, we also know where the turning point is. Okay, and that is at 2 minus root 3. 2 minus root 3 is still positive. Okay, so it will be somewhere here. Okay, 2 minus root 3. How do I know that 2 minus root 3 is positive? Well, because you see 2 minus root 3, okay, is actually between 1 and 2. Okay, why? Because if I were to square everything, I know that 1 is actually less than 3 but more than 4, right? So if I square root, okay, backwards, I know that 1 is root 3 is less than 2. So 2 minus root 3 cannot be less than 0, alright? So I know that the point is going to be here, right? So that's all I know. So I just need to kind of like make my wild guess, okay? Because I don't have a paper, calculator on this paper, right? So I just need to kind of like draw it roughly. Okay, so as long as it passes through the key points, okay, I'm good. Right. Part C now. Show that, okay, 3 over x plus 1 minus 1 over x minus 1 equals to that. So let's just combine the fractions. X minus 1 times x plus 1. This is 3 times x minus 1 minus 1 times x plus 1. And so that's 3x minus 1 minus x minus 1 over x squared minus 1, which turns out to be what I wanted. Sorry, this is minus 3. So this is 4 over here. Okay, so it's really important to show all the steps, okay, in this working. Okay, so because the answer is given to you. Okay, part D, the area enclosed by the graph of fx and the line y equals to 4 can be expressed as ln of v. Find the value of v. So let's look at the graph once again. So I want to find the area between this graph and the line y equals to 4. Okay, y equals to 4 is here. So I need to basically find this area, okay, over here. So I guess I can take the area from 0 to whatever point this is, okay, which is the point of intersection, right? Okay, and then I can take the area under the line y equals to 4, which is like a giant rectangle, okay, subtract that to the area under the curve from 0 to 4. Okay, and so that's what I'm going to do. Alright, so first I'm going to find the intersection. So fx, okay, I'm going to let it equal to 4. Alright, so 2x minus 4 over x squared minus 1, no square, x squared minus 1, I'm going to write it equal to 4. So therefore 2x minus 4, I can solve it to be 4x squared minus 4, 4x squared minus, minus 2x equals to 0, so 2x times 2x minus 1 equal to 0, so x equals to 0 or x equals to half. And so from the graph you can see that x here, the one that I'm trying to find, has to be half, okay, because 0 is already on the other side. So the two limits of the area under the curve is actually 0 to half. Okay, so therefore the area under the curve is integral from 0 to half of fx, 2x minus 4 over x squared minus 1, alright, dx, which based on part C, okay, is actually equal to 3 over x plus 1 minus 1 over x minus 1, okay, kind of like partial fractions. So this is 3 ln of x plus 1 minus ln of x minus 1, evaluated from 0 to half. Okay, I'll continue up here. This is 3 ln of 3 over 2 minus ln of minus half, mod of course, minus 3 ln of 1 plus ln of 1. Okay, the good thing is that these two are both 0, so don't need to worry about it. Okay, now let's just evaluate this. So this is 3 ln 3 over 2 minus ln half. Okay, 3 of ln 3 minus ln 2, okay, minus ln 1 minus ln 2. Right, so this is 3 ln 3 minus 3 ln 2, then minus ln 1 plus ln 2. Okay, so this is equals to ln 27, then minus ln 4, which is ln of 27 over 4, okay, because ln 1 is 0. So the required area, okay, is equals to the area under the rectangle, okay, minus the area from as found above, right? So that's going to be half times 4 minus ln of 27 over 4. Okay, half times 4 is the area of the rectangle. So that's 2 minus ln 27 over 4. Okay, which is, well, if we want to make it into one thing, so this is ln of e squared minus ln of 27 over 4, right? Ln of e squared over 27 over 4, which is ln of 4e squared over 27. Okay, and so therefore v is equals to 4e squared over 27. Alright. 11. Points A, B, C, and V form the vertices of a tetrahedron. Okay, let's do A first. Show that AB cross AV is that. So AB, let's find that first. That's 0, 10, 0 minus 0, 0, 10. So that's going to be 0, 10 minus 10. AV is equals to P, P, P minus 0, 0, 10. And so that's P, P, P minus 10. So AB cross AV is equals to 0, 10 minus 10 cross P, P, P minus 10. Okay, and then, well, we need to kind of compute it out. So that's going to be 10p minus 100 minus p times minus 10. Okay, second row is minus of 0 minus p times minus 10, and lastly the last row is 0 minus 10 times p. Okay, so this is well, it's 10p minus 100 plus 10p. Okay, second row is 10p minus 10p minus 10p at the end. Right, so that's minus 10, factorizing that out. 10p minus 10, or 10 minus 2p, then p and p as required. Right. As for AC cross AV, let's find AC first. So AC is 10, 0, 0, minus 0, 0, 10. So that's going to be 10, 0, minus 10. And so AC cross AV will be 0, 10, 0, minus 10 cross P, minus 10, P minus 10. Right, and so you get 10 after doing the working times P, 10 minus P, 10 minus 2P, and P after some working. Hence, part 2 show that if the angle between ABV and ACV is theta, then cosine theta is equals to that. So this is really the angle between the two faces, which is going to be found by taking the dot product of the two normal vectors of both faces, which are AB cross AV and AC cross AV respectively. Okay, so I'm going to consider now the cross product, the dot product of these two vectors, 10 minus 2p, p, dot with 10 times p, 10 minus 2p, p, okay, and so this gives me mod of minus 10 times 10 minus 2p, p, mod of 10 times p, 10 minus 2p, p, cosine of the angle between them. Alright, so this is minus 100 times 10p minus 2p square plus 10p minus 2p square plus p square equals to 10 times square root of 10 minus 2p square plus p square times 10 times root of p square plus 10 minus 2p square plus p square times cosine theta. Okay, the good thing is that this expression actually kind of like cancels each other out. Right, so this is minus 100, okay, times 20p minus 3p square equals to 100 times 10 minus 2p square plus 2p square cosine theta. So cosine theta is equals to 3p square minus 20 over 10p square 10 minus 2p square plus 2p square plus 2p square, which is hopefully will reduce to what I want. So this is 100 minus 40p plus 4p square, then plus another 2p square. Right, it does work. 20p minus 20p. Oh, but they want it in that form, so let's give it to them. 3p minus 20 over 6p square minus 40p plus 100. B. Okay, B part 1. Consider the case where the faces are perpendicular, so that means that theta is 90 degrees. Okay, so if theta is 90 degrees, that means that cosine of 90 degrees is 0. Okay, and so therefore the numerator of that fraction that we just found will be 0. So that means that P is actually 0 or P is 20 over 3. And so the coordinates, possible coordinates of V are 0, 0, 0 or 20 over 3, 20 over 3, 20 over 3. Part 2, comments on the positions of V in relation to the plane ABC. Well, what I think we will be able to see is something like this. Here's the plane ABC, okay, well, the point V, okay, when this is 90 degrees, okay, it can either be here, but it also might be on the other side. So realistically, geometrically speaking, we can see that the 2 points are on opposite sides of the plane. ABC. Okay, now for the most challenging part of the paper. C. The following diagram shows a graph of theta against P. The maximum point is shown at X. Part 1, find the value of P at X and the value of theta. Okay, so doing it by differentiation isn't very helpful. This is how I think we can think about it. You see, if you look at the tetrahedron, okay, like this, okay, where maybe this is the angle, okay, over here, this, imagine this is A, B, C, V, okay, so the angle between the faces is this angle, okay, over here, away from me, okay, this angle here. Right, so if I increase this angle, okay, I can increase up to 180 degrees, okay, and then see at 180 degrees, these two faces are actually parallel to each other. It will be like that, okay, imagine it will be like A, B, C, and then V. It will be a one flat surface, okay. There's no tetrahedron, all right, after that, but theoretically, after you increase after 180 degrees, the tetrahedron will actually form and fold on the other side. Okay, you can imagine right? Folding it like away from where you originally put it. So the vertex will appear again, but the tetrahedron will be formed on the reverse side of where you had originally drawn your tetrahedron. Okay, so actually that tells me that the maximum value of theta, okay, is actually at 180 degrees. That will give me the maximum value, theoretically at least. Okay, even though you don't have a tetrahedron when theta goes to 180 degrees. Okay, so at X, okay, we can see that theta is actually 180 degrees. Okay, and so cosine of 180 degrees is -1. So what I'm going to do is I'm going to solve this equation. -1 equals to P times 3P minus 20 over 6P squared minus 40P plus 100. Alright, so 3P squared minus 20P equals to minus 6P squared plus 40P minus 100. So 9P squared, okay, both over minus 60P plus 100 equals to 0. Let's see. Okay, so let's solve this now. So I guess I can use quadratic formula. P equals to 60 plus minus root of B squared, 3600 minus 4AC, 9 times 100 over 2 times 9. Alright, so this is 60 plus minus root P of 3600 minus 4 times 9 is 36, 3600 again over 2 times 9. So this is 60 over 2 times 9, and that gives me 10 over 3 actually. Right, so that's the value of P, and the value of theta is 180 degrees. Okay. Part 2 now. Find the equation of the horizontal asymptote of the graph. So horizontal asymptotes are always what we do when we let P tend to infinity. Okay, so if we let P tend to infinity, okay, what we want to see is what happens to the value of cosine theta. Right? We can tell what happens to cosine theta. Cosine theta will actually tend to whatever value that 3p squared minus 20p over 6p squared minus 40p plus 100 tends to as p tends to infinity. So let's calculate that first. Okay, let's limit as 10p to infinity. So we can see that this is a indeterminate form. So let's use L'Hopital's rule now. Okay, L'Hopital's rule on this, we get 6p minus 20 over 12p minus 40. Okay, still indeterminate, so let's do L'Hopital's rule again. Okay, on it we get 6 over 12, which is no longer indeterminate, but we can evaluate it as half. So I know that cosine theta will tend to half, okay, as p tends to infinity. Okay, but all we want is theta. Okay, so now we need to realize that theta actually tends to arc cosine of half, okay, which is actually pi over 3. But I just want you to note that this is only true because, okay, the function cosine is a continuous function. Okay, so if it's not continuous, it may not necessarily be true, meaning that you see, limit as p tends to infinity of cosine theta is the same as cosine of the limit as p tends to infinity of theta. And actually what we were looking out for was this. This was our goal. We wanted to see what happens to theta as p tends to infinity. Okay, but all we had was an expression for cosine theta. Okay, but because cosine is continuous, these two limits are actually the same. Alright, so that's it for our review of the 2019 IB HL November Paper 1. Hope you enjoyed it, okay, and please ask your teachers if you have any further questions. Thank you.